Welcome to The Explainer. I am absolutely thrilled to have you here today because we're embarking on an incredible journey. Think of the history of science not just as a standard timeline, but as this vast, interconnected map spanning across millennia. Today, we're going to trace the very blueprints of human curiosity. Okay, let's dive into this. When you picture the history of science, what actually comes to mind? A lot of us were taught to imagine a perfectly linear, unbroken chain of brilliant discoveries, often exclusively centered in the West. We tend to imagine humanity just marching straight up a grand staircase of knowledge. But as we'll see today, that assumption misses the true, messy, and totally fascinating reality of how we actually learn about our universe. To really shatter that illusion of a straight line of progress, consider how scholar Alfred Edward Taylor describes certain eras. He called them periodical bankruptcies of science. It's a pretty powerful phrase, right? It reminds us that knowledge isn't just cumulative. Sometimes profound understanding is gained, only to be completely lost for centuries, and then miraculously found again. And the history of science is massive, mainly because science itself isn't just about test tubes and telescopes. It encompasses the whole shebang. We're talking everything from the natural philosophy of physics to the formal logic of mathematics, all the way to the social sciences that study our own human behavior. It is a comprehensive pursuit of understanding. So here is our roadmap for this global relay race of human knowledge. We'll trace the roots of scientific thought, the global knowledge relay, the scientific revolution, ages of new discovery, the era of big science, and finally, rethinking the scientific story. Section 1. Roots of scientific thought. This is where humanity first began making documented observations of the physical world. Formal attempts to understand natural causes started globally long before the modern era. By 3000 BCE, civilizations in ancient Egypt and Mesopotamia were already laying down the foundations of mathematics, astronomy, and medicine. Over in Mesoamerica, around 500 BCE, the Zapotec civilization established incredible traditions of astronomy to produce highly accurate calendars. By 400 BCE, Greco-Roman thinkers were formalizing natural philosophy. But remember, progress isn't permanent. Around 400 CE, with the fall of the Western Roman Empire, that Greco-Roman knowledge heavily deteriorated in Western Europe. The staircase was suddenly broken. Section 2. The Global Knowledge Relay. We often hear the early Middle Ages called a dark void, but it was actually this vital period of preservation where a massive relay race began. While Western Europe lost touch with Greek conceptions, the baton was passed over to the Byzantine Empire for preservation. Then this knowledge was absorbed and vastly expanded upon during the Islamic Golden Age. Finally, between the 10th and 13th centuries, these texts were translated back into Latin, completely reviving Western natural philosophy. And we absolutely cannot forget that while this Mediterranean relay race was happening, massive, independent marathons of discovery were occurring elsewhere. Ancient India and China were developing incredibly robust scientific traditions. In fact, the Chinese model heavily influenced the historical development of science and technology in Vietnam, Korea, and Japan, well before any Western exploration. The pursuit of knowledge was truly a global phenomenon. Section 3. The Scientific Revolution. Now, what's really interesting about this era is that it was an explosive turning point because it fundamentally shifted our whole approach to knowledge. Previous Greek conceptions were heavily philosophical and qualitative, but the new science became deeply mechanistic. It integrated high-level mathematics, and it was grounded in a rigorous scientific method that demanded repeatable reliability. The sheer velocity of discovery during this time was simply immense. We saw Copernican heliocentrism redefine our place in the cosmos. We saw the invention of calculus and Newtonian mechanics map out the actual laws of physics. Alchemy began giving way to the emergence of early chemistry. And in biology, we got the paradigm-shifting discovery of the circulatory system. Human understanding was effectively put into hyperdrive. Section 4. Ages of New Discovery. Moving into the 19th century, we fundamentally rewrote the rulebook all over again. The conservation of energy completely reshaped physics. Geologists finally began to grasp the true ancient age of the Earth, stretching our timeline back millions of years. Biology was revolutionized by theories of evolution and inheritance, while medicine was completely transformed by germ theory. We even saw the birth of modern social sciences like psychology and sociology, applying this rigorous scientific method to human behavior itself. These weren't just academic shifts. They fundamentally rewrote our understanding of who we are and drastically improved human life expectancy. Section 5. Era of big science. This is where the classic image of the lone natural philosopher tinkering in a personal study pretty much disappears. Discoveries of the 20th century, things like Einstein's relativity, quantum mechanics, and the mapping of genetics, were so profoundly complex that they required entirely new ways of working, laying the foundation for hyper-specialized subdisciplines. You couldn't just be a general scientist anymore. You were a molecular biologist or a particle physicist. So the really crucial point here is that science evolves into an unprecedented institutional powerhouse. Post-World War II, we enter the era of big science. We are talking about highly complex, massive-scale research endeavors driven by government funding, industrial needs, and military concerns. Think of gigantic particle accelerators or the space race. It forever changed how research is conducted, turning science into a monumental collaborative force. Section 6. Rethinking the scientific story. When historians look back at this timeline today, they no longer see a simple, triumphant story of linear progress. Science is, inherently, a human activity. It's characterized by proliferating specialization, deep global exchange, collaboration, and yes, sometimes conflict. It's a messy, beautiful web of diverse cultural contributions that reflects the societies producing it. A perfect example of how our understanding evolves is the relationship between science and religion. Take John William Draper's 19th century conflict thesis. That's the idea that the two have always been strictly at war methodologically and factually. Now, while some contemporary thinkers still subscribe to this, modern historians observe a much more complex historical relationship. They recognize periods of tension, for sure, but also profound harmony and mutual independence depending on the specific era and culture. We've seen that knowledge can be lost, recovered, transformed, and expanded across continents and centuries. If the history of science is truly a shared human relay race, this ever-evolving web rather than a straight line, what incredible boundaries are we going to break next? Thank you so much for joining me on this explainer. Keep questioning, keep learning, and I'll see you next time.